Hi, Simone, how are you doing? Oh, I'm not sure I can hear you at the minute, Simone. Are you on mute? I'll tell you a little bit about Simone while we're sorting that out. Simone works.
Sorry.
Oh, there we go. Hello.
Yeah, everything is fine here.
That's good. Simone, you work at the same company as me. You work at NearForm, right?
Yes, of course.
And how long have you been with NearForm now?
I've been there for 9 months, more or less.
Cool. Yeah, it's great to have you here at NodeConf this year. And I want to just ask you, what was your first public software application that you worked on?
Yeah, I built a software to edit a PlayStation game back in 20,000 or less. In 2000, sorry, 2000 or less. Yeah, and I publicly that, of course.
Okay, well, you are going to do a great talk for us today, so please welcome the very wonderful and Linux Foundation certified Simone Sanfratello with Do TypeScript Without TypeScript.
Yeah, thank you. Okay, hello everybody, and welcome to NodeConf. We do really hope this is the last time we meet virtually. Let me introduce myself. I'm Simone Sanfratello, and I'm a senior software engineer at NearForm. And hey, we are hiring. We are a cool company. We have a lot of open positions. Check them out. Today we are talking about TypeScript, so let's start. TypeScript 1. TypeScript is one of the most trendy languages in the recent years. Everybody loves TypeScript. As we can see in the last Stack Overflow survey, it's the third most loved language and the second most wanted language. So people enjoy working with it or want to start using it. In JavaScript, there are different types of static code checkers. One of the first one is JSLint by Douglas Crockford, one of the authors of JavaScript about 20 years ago, when dealing with globally scoped variables and closure weren't easy. And then a decade later, new static code checkers started. While ESLint is essentially the evolution of JSLint, big companies had different approaches. I mean to introduce also type checking. Flow and Glue closure compiler added type checking with annotations, so essentially with structured comments. TypeScript instead does type checking as an extension of the JavaScript syntax, and also introduced other features that weren't available to the language at the time. For example, default function parameters or private class fields. And indeed, it defined itself at the time a JavaScript superset. But what types are for? I mean, every programming language has types because it's the way to read and write data in memory. We can say type contains information about the size and the encoding of variables. I'm simplifying that just to get the point. In weakly typed languages like JavaScript, the type system is implicit. This is not an issue, it's design choice. And so we don't need to write types of variables because they are deducted. Instead, in strongly typed languages, as TypeScript, the type system is explicit, so we have to write the type of variables before using them. But why do we want explicit types? Which are the problems we want to fix through TypeScript? We want to know how to operate with variables and avoid unexpected results. As we can see in the example here, it's a very basic case where the implicit cast on different variables types lead to an unwanted result, and it happened very often. And also we want to know what's inside the object. We want to know what the properties and members of our objects are. For example, here we had the event from the event emitter of the Node core library. And we want to know what are the properties and members of the event. And also we don't want our object to change their structure at runtime, or even worse, that our variables change types at runtime, because JavaScript allows to do that. And also we want to know what the signatures of our function are, without going to see in the documentation, if any, or if there is no documentation, we have to go to check that in the source code. But there is an exception where the implicit type system works very well, and it's with number. JavaScript handles numbers properly, and we don't feel the need to specify if we have to use a double or an assigned int or so on, because of course JavaScript casts them properly and we get the right result. And we don't even can't specify that in TypeScript. We just have the number type. Types are also used with modeling. In the example here, we have the user with its properties like ID, name, email, and so on. And by chance, there are all strings. But while there are all strings, there are different kind of strings, different kind of values. So we might want to express something like that, where the strings have different contents, of course. But doing this with types is something that is not very effective. And the most effective way is to do this using input validation. Input validation is a good practice to ensure data quality and also to reduce the surface area for attacks like injections. Without a validation, we may get correct types, but still wrong values. And we should use validation on the inputs of our application, for example, on API entry points, on user inputs on the front end, or in parameter of the functions of our libraries. And so we put a barrier as soon as possible to the values we want to accept. And of course, we can do this with types. And of course, we need tests. As we can see in the famous test of shape, static type checking stays at the bottom, and it checks only the integrity of the code. But they need all the other testing layers in order to get robust applications. We all know with unit testing, we can check the proper operation of the smallest building blocks of our application. And with integration tests, we can check business logic and so on. And of course, with end-to-end tests, we can check our application features. The test suite can detect issues on the running application, not only on the static code, and we can also detect, we test wrong type declaration that we could do. And in the community, TypeScript is synonymous with safety. But as we've seen, type checking can only detect issues on the very first layer. And let me explain. It's like, I mean, I do woodworks, and it's like wearing gloves, handling a chainsaw. When I handle a chainsaw, I'm afraid to cut my finger off. I'm not afraid of scratches that gloves can prevent. So when I write an application, I'm afraid of security issues, that my application doesn't scale, that I do that I made mistake on the business logic, especially when money is involved. And types error can solve them, and types error can easily fix it. And so while a death by 1,000 cuts is a thing, a death by 1,000 scratches is not. And also another feeling I get is that TypeScript is like JavaScript plus types, but that's not like that. I mean, with TypeScript, we get some features and some checks, of course, but also we lose some capabilities of JavaScript. So, for example, TypeScript introduced earlier optional chaining before JavaScript, but at the same time, it has ECMAScript module support only in months or so. So we have to consider that TypeScript is something that is a little bit different from JavaScript. And what are the TypeScript benefits? So, of course, it does type checking with expressive syntax, and we want to get rid of type errors at runtime, like enable to get X of undefined, or undefined is not a function, and we want to detect that and prevent as soon as possible. And also it reduces the cognitive load on a project because it is allowed to learn a new code base more easily for developers. And it's also useful to introduce to JavaScript developers that are used to coding with typed languages, and at first JavaScript is a little bit alien to them. It's still JavaScript, so it has the same performance, and the transpiled code is very close if it was written directly in JavaScript. And so we don't need to learn a new language. We can still just use the same JavaScript APIs. TypeScript enhances documentation and modeling because of explicit type declarations. And so the code contains also this information. And because of that, IDE can do code completion and error highlighting, as we can see in the example here. There are, of course, some drawbacks. The main one to me is there are many forms of TypeScript. For example, here, depending on the compiler options, and we can get different behavior of TypeScript. And so this operation can be allowed or not, for example, and this could be confusing for a developer that works on different projects with different TypeScript configurations. And just to say, there are 18 flags for type checking for the compiler option, without mentioning the modules options. TypeScript also reintroduced the wait for the compiler stage before running. I mean, JavaScript is great because we just write code and it runs. We don't have to compile to code machine. Instead, with TypeScript, we have to transpile that before running it. And this is not honestly a big deal on the front-end projects where we already have a tool chain to produce the final code, but in the back-end code, this is not really needed. And also, there are some operation limits, again, depending on the configuration, but there are, but this kind of operation is not usually allowed on TypeScript. And while this is probably the reason why we use TypeScript to prevent this operation, this is also a limit to that. To them. And also, another example here, this code is perfectly fine. It works properly, but TypeScript doesn't allow to do that. We also need more tools working with TypeScript, for example, TS Node, TS Jest, and custom debugger configuration, and so on. And it also, my feeling is that typing testing code slow me down. I mean, I want to write more tests as possible in the easiest and simplest ways possible, but I have to type the testing code, the test doubles, helper, and so on in order to run my test. How can we get the benefits of TypeScript, as we've seen, reducing the cost of adopting it with JSDOC, with the good old JSDOC. Combining JSDOC and TypeScript with type checking, we can get the benefit like type checking, of course. We can define our entities and objects and models. We can assign our functions, and so achieving IDE support, and we don't have features loss. And that's great. Like, I mean, we can do a couple of operations, so we don't have to transpile code in order to run it. I can run, for example, the type checking in a different task of test, because of course I usually run test a lot of times while developing. So we can. I don't have to transpile the code for running tests, and we can also export types. The TypeScript is great, so because you can read the JavaScript, the JSDOC syntax, and produce the type files. So code time. Let's see an example of what I talk about. So let's suppose to write a command line, a very simple command line application. So npm init and npm install TypeScript, of course. TypeScript, JSDOC, and types node. And while it installs, I start defining the TypeScript configuration. So I have to say the compiler options that are allow.js and strict mode, of course. And also it has to check the JavaScript code. We want to produce the declaration, and this is our declaration directory. Then we want to include JavaScript files, and of course, excluding node modules. And our scripts, in order to work with that, here's the check script, that is TypeScript, no emit true. So in this way, I just check the code without producing the transpiled code, and export. I mean, I want to export my types, emit declaration only, and I don't want to do that if there are any errors. Okay, so then I can write my code. I can write my code. I say use strict because I know someone that add it at the top, like usually TypeScript does. And then I use this magic keyword tscheck. So I tell the transpiler to check this file. Let's say, sorry, I have my main function. Let's say I want to write a very, very basic application to subscribe a user to a newsletter. So I have the name that I get from the arguments. And then I have the email that again I get from arguments. And here I can start typing my variables, like those are strings. And then I run the subscribe function with the email and the name. Then I go to define the function. And now it is the user. So again, I can define this as a user, and the type checking start to hitting me like there is no user. So okay, I'm defining it. And sorry, type def. There is the email and the name, and you're fine. And here, if I start doing something that is not okay, it starts saying that name is not a number and is a string, and it works. And then here, I should, yeah, of course, save to storage and send the welcome email to the email address. User email, let's suppose. Again, I have to define my function. And I can again define my signature, the signature of my function. And also add in some comments, of course. So let's say some console log. And again, if I have some, if I do if I made some mistakes, the type checking is telling me on my IDE. Or I get, for example, auto-completion. And here, because it's a user, it says that I have the email or name to pass to the function. And of course, I can define what I expect to return. And again, if I don't, the checker is not happy. And yeah, okay, so here we go. We can run the check task. There are no issues. Yeah, and now I want some issues here. And of course, the type checking is telling me that is not okay. Or I want to run my code, even if I have some issues like this. So the type checking would not pass, but I can still run my code. So the first one is the name. and the code is running, even the type checking is not happy. Yeah, okay, we could go on, but we get the ID support, we get type checking, and we get that only using type notation with JSDOC. Yeah, so thanks Node.com for having me. Here you can find some code for what I've shown. Feel free to reach me out. Special thanks to my friend Duana that helped me preparing this talk.
Hey, Simone, thank you very much for that. And thank you for being so brave and doing a live coding demo to all the people out there. It's been really, really fantastic watching that. You have had quite a debate sparked up on the chat room. It's probably worth you having a read through it later, but there was a really nice comment from Stephen Bellinger. He said that TypeScript is great on large code bases, but not so great on small ones. Would you agree with that?
Yeah, most of the time I agree with that. I mean, I've seen we get a lot of benefits with large code base where it's easier to put a tool like, to use a tool like TypeScript as let's say a gateway for code before coding reviews. So everybody, we set some rules that everybody has to follow, and what the feature we lose are not that. I mean, we get more the code quality we get worth the restriction we have on the JavaScript code.
Yeah, I can understand that. So, oh, here we go. Luciano is asking, oh, sorry, no. Peters asks first, why not d.ts instead of JSDOC?
Yeah, I mean, you can, I think it's more straight to use JSDOC because you can write comments straight in the same place where the code is. So you have a function and you don't have to write the definition in a separate file. And also you can add comments and use JSDOC for that. I mean, yeah, of course, you can also write comments on the .d.ts files, but JSDOC can also produce, I mean, TypeScript with JSDOC can also produce those kind of files. So while the two operations are basically equivalent, I think JSDOC can be more useful because you put all that in the same place with the code.
Cool. No, that is a good point. So Luciano, our previous speaker's got a question for you as well. So he said, Simone, can we use this approach with complex objects with many fields and nested attributes?
Oh, yes, of course. We can, of course we can. We have to describe that, of course. We have to tell what the types, what the object structure are and what we expect. But yes.
Brilliant. Okay, and I'm just looking. Oh, here we go. Adrienne says, what is the drawback of using this versus TypeScript? What does TypeScript bring that this doesn't?
Oh, I don't get it. Sorry.
That's okay. So I think he's talking about the approach that you've taken versus TypeScript. I'm not quite sure.
Oh, I mean, why this and not TypeScript as, yeah, and not TypeScript as a language? You say.
Yes. Yeah.
Okay. So. Yeah. I mean, this approach is, I think, like a kind of light TypeScript. So we have type checking. I mean, we get the benefits, and we are not. We don't need to transpile the code in order to run it. And this approach, we can have with that we can introduce type checking gradually in a project that is not using it, or and we can decouple operations, like we can do type checking in a task and run the code in another one. And that's it. I mean, we can avoid the smiling code. That's a step that slow me down.
Yeah, the transpiling it always takes a few seconds, and over time that adds up. So I can understand your point of view on that.
Yes.
Thank you so much, Simone. Yeah.
Thank you. Thank you.
Thank you very much. If anyone needs to get in touch with you, if you've got any more questions, Twitter or?
Of course, Twitter or email.
Out to you on. Brilliant. And your contact details are up on the NodeConf Remote website. So, okay. Thank you very much, Simone.